everybody. I'm really happy to be here with you today. I'm Anne-Marie Fred, as he said, from IBM. I'm DevOps lead for the Commerce platform, and what that is the organization that runs a good chunk of IBM.com, specifically the product pages, pricing information, checkout, live chat, search and navigation. Just to preface this, we have great lawyers. I'm not an IBM spokeswoman. My thoughts are purely my own. So there are only two types of companies, those that have been hacked and those that will be. That's Robert Mueller, the former FBI director. So what are you going to do about it? The fact of the matter is that a tiny security team can't keep up alone. They really need help from our developers, our DevOps teams, our IT operations staff. Now, in my organization, if you look back maybe 2 years ago, we were already doing many things that are very important, right? We had our cybersecurity and privacy training. We taught people how to report and recognize possible incidents. We had our self-assessments, the audits, very comprehensive security standards, data and privacy controls. We had automated web test security suites and vulnerability scanners, firewalls and WAFs, monitoring and log analytics, and these corporate rollouts of security tools and initiatives. But that's just table stakes. That's just the minimum, just checking the check boxes. We have to go beyond that to keep up. So if I was to contrast what traditional IT security looks like as opposed to DevSecOps, this is how I would do it. Traditional IT security involves a lot of top-down mandates, and security tends to be an afterthought. It's something you apply at the end of your release cycle. Tools and processes for security are very manual. We have a lot of checklists and spreadsheets that we have to complete. We have a few specialized security experts, so the ratio of security experts to developers is very low. And a lot of the visibility control over the security program is done at the corporate level. With a DevSecOps program, what we have is a bottoms-up security program where all of your technical staff are involved in security. We shift left and get security involved as early in the process as we can. We have excellent automated tools. We have highly engaged developers and operations staff. We have frequent sharing of expertise in security between different people. And a lot of the visibility and control moves down to the application and service level. So if you want to go beyond the boxes and just doing the minimum, how are you going to engage your developers and your operations staff? I'm going to spend the next 20 minutes talking about what we're doing. First, you want to show them the threats. Make it interesting and concrete so they see, why does it matter to me? So which one of these has more impact? Column A. There's a possible injection vulnerability in your app. Or column B. Here are the actual logs from this morning of hackers trying to inject something into your database. Column A. It's theoretically possible for somebody to try to launch a distributed denial of service attack against your app. Or here's an attempted denial of a service attack on one of your services that's happening right now. Obviously, it's the second. It's actually not very difficult to do this. You can just start by looking in your logs for alert, script, and etc. And here's a couple of examples on this slide. So on the bottom left is like a New Relic query that's checking for transaction error messages for a specific application and faceting by error message. And on the bottom right, you can see what that graph looks like. And we actually expected a lot of our errors to be 404s, but then we see all these like failed to decode param and no such file or directory. What does all that mean, right? Well, then if you look in more detail in the logs in the top right, the one in the enotdir one is actually a script alert tag that somebody was trying to insert into the URI. And on the upper right, the failed to decode param, you can see they were trying to read from //////etc., right? So this is what it looks like in your logs, and it's actually very simple to find that. You can also let developers see their own web application firewall in action. So How many times is the rate limiting on your APIs making a difference? Where are the attacks coming from? What kind of, how many IP addresses are we blocking? Things like this. A lot of times when this is controlled at the corporate level, your development teams aren't seeing this. You can also help them set up runtime application self-protection agents. So these are agents that plug into individual applications, and they can see all of the suspicious traffic that's coming in that's still getting through your web application firewalls. And since they are inside your application, they can often do a much deeper level of analysis and threat modeling for you. You can also put live firewall and RAS charts on the wall. So actually, this is an example of some monitoring data that we have for our GitHub and Travis environment on the wall. And the nice thing about this is that people will casually notice it as they walk by. So a lot of attacks on your system are going to be very fleeting. It might just be a minute or two where somebody will run a whole bunch of things, and it'll show up, it'll light up on your dashboards, but if nobody's watching it, you won't notice, right? But if it's in a public area, you'll see it happening. Bug bounty programs are another excellent way to show people, what actual hackers are trying to do. So a bug bounty program, if you're not familiar with that, is where your company sets out some rules in a bug bounty program and says, okay, if you follow these rules and try to attack our system and find a vulnerability and report it to us, we'll reward you for that. And that might sound very scary at first, but the US government does it, IBM does it, other major corporations do it. It's a best practice. And if you show your developers the reports that are coming in from those programs, they can see that this is all very real to them. And they'll be very motivated to fix it quickly. Next, we have to teach all of our technical staff what it is that they're looking for. Everybody should have some application security 101 training. A few things that this should cover. What are the most common vulnerabilities, right? How to validate your input to make sure that there's nothing you're not expecting. How to escape your output. It should be impossible for somebody to put input into your system, have it go all the way through the application without being validated and scrubbed and come out the other side. And how to prevent information exposure that makes it easier for hackers to find out how to attack your system. They should not know, they should not be getting stack traces if they cause an error in your system, for example. Next, we want to give our development teams control. And this is a fundamental tenet of DevOps, right? Ownership and responsibility. So put your development teams on call. They need to be in the on-call rotation. This is the #1 most important thing you can do to increase the quality of your applications and how easy they are to run in production. This is one of our people that I work with here, Craig. We also want to teach our developers how to set up their own monitors and alerts. They know their applications better than anybody else, and it's not rocket science. We can teach them how to do this. Specifically, we can create monitors and alerts for security events. So this is an example of one that I created. It's an NRQL outlier detection in New Relic. And what it's saying is that in a 5-minute period, I got an unusual spike in errors. This is detecting that we ran a security scanning tool against it, and every day it emails me that it detected something, which is good because I know it's working. You can also let your developers tweak their web application firewall and RASP reporting and blocking settings. Don't just take what's out of the box. They can tell you in more detail what sort of services they're expecting to connect to, what sort of requests they're supposed to get, what they're not, and so they can tune those settings with you. But wait, what about separation of duties? Segregation of duties, right? It cannot be possible for one developer to make a code change, put it in production, turn off the monitors that would detect a problem, right? Well, the way that we handle this is with multiple layers. So we have the web application firewall controlled by our corporate webmaster team. So they'll make changes if you request them, but it's totally separate from the development teams. Then the web application firewall that the developers control is the second layer of security on top of that, and the RASP tools are another layer of control. We also have overlapping monitors. So we do let our development teams control the alerts for their own application performance monitors and the synthetic monitors that are simulating what it looks like for somebody outside of the network to hit the application. But we have additional monitors on top of that. We have one type of monitor that I would call a user journey monitor, where we've scripted running through the system and making sure you can find a product and get your subscriptions or check out. And we also have top offering monitors that are watching all of our top offering pages to make sure that they're up and pricing is showing up as we expect and things like that. So by having multiple levels, we make it much more difficult for anybody to make us blind to a problem. Another very important thing, and this is some advice I got from Zane Leckie, actually from Signal Sciences, is that we have to reduce the toil. But let's be honest. In the past, usually security was just a lot of work, a lot of paperwork, and check boxes, and not a lot of fun. So with DevSecOps, we need to automate our security checks so that we do it once, and then we don't have to worry about it later. One thing we can automate is dynamic web application security testing. In my organization, we run these daily. So these are like black box tests that run, you can point them at your web applications, you can point them at your APIs, and they'll just run a standard set of checks. They'll try to do injection attacks and cross-site scripting, and they'll generate a report if there's a problem. And it's good to have some tests that are running every day, because if you happen to not deploy an application for a week or a month, at least you're getting some tests that are running all the time. We also have our known vulnerability scanning, which we want to run in the development process and the test process. So what I have here is an example of NPM audit. And this is something that's free for all Node developers. You don't even have to upgrade to the latest version of Node to use it. You just have to upgrade to the latest version of NPM. And every time you run npm install, it's going to run audit and give you a report that'll say, hey, by the way, you have 28 known vulnerabilities, right, in your application. And it can automatically fix a lot of those for you by choosing a different version of the package that's not vulnerable. And then some of them will require manual review because it can't fix automatically. So our goal is that we get down to 0 vulnerabilities. Then we put that check into our unit tests. We put that check into our build pipeline so that if the next day you go to deploy something and suddenly you have 2 new vulnerabilities, it will stop that from going to production. Another thing we do is static application security testing. So this is basically static code analysis that we run. And these static code analyzers can find a lot of common security problems, like taking input and not validating it, right? So we run those as part of our regular unit test process and also in the build process. And again, these can fail your build. The next level is interactive application security testing. So these static tools and these black box tools can't hit all of your code paths, but if you have excellent test automation, you're probably hitting 100% of your code or close to it. These tools will watch as you're running your normal test suite and find which paths your code is executing, find places where you're not scrubbing your input and output for you, and find which of the possible vulnerabilities are actual vulnerabilities. So these are great because they help your developers determine which are the real problems and which are the false alarms. And then runtime application self-protection. Now this is not as helpful in the dev process, but it's really tailored for when your tests are running or in your staging environment in production. They watch to see real traffic come in, right? And they find patterns in the traffic that are likely to be attacks against your system, and they can alert you to that. And speaking of alerting, you should alert your developers to the anomalies. Alert them when you find a vulnerability, when you find a code smell, from the static code analysis, when your tests are failing, when your monitors are going off. This might sound like it would just be really annoying and your developers would be constantly pinged and it would be like crying wolf. But the fact of the matter is, when you roll out a new tool, you'll probably get a lot of alerts for a couple of days. Then the developers will clean it up and it'll be quiet. And after that, they can rest easy knowing that if they're not being alerted, then there's not a problem. And I have a couple of examples. One of them, these are both from our daily test running, right? In the top right is one saying it's detected a lot of errors, and in the bottom right is Web Application Firewall telling us that it saw a lot of what looks like cross-site scripting. Another key tenet of DevOps is infrastructure as code, and this can make it a lot easier for you to automatically lock down your production systems, so you should. For example, you can allow only HTTPS traffic. Don't allow HTTP. You can prevent SSH into your production systems. You can make sure that you're running the latest patches on your operating systems, right? You can whitelist and blacklist different addresses. Okay, so now that we've automated as much as possible, and this is just running all the time, the other thing that's very important with DevSecOps is to share what we're learning. We want everybody to become a bit of a cybersecurity expert. So a couple things that we do. One is we have tech talks and lunch and learns, and these are very informal, peer-to-peer, and they're just knowledge-sharing sessions. What have you learned recently that would be useful to other people who you work with? How have you gotten more out of our tools? Have you tweaked it to make it better? Or we might do a deep dive into a vulnerability we just heard about in the news. Or we might talk about, hey, here's a security issue that our tools just found, and here's how we fixed it. We also have these micro talks, which are just 2 to 10 minutes, where we talk about security topics every single week in our developer guild meetings and our operations guild meetings, and it just keeps these topics top of mind for people. So maybe one week we talked about how to keep secrets out of your source control, and how to, there's a tool called Detect Secrets that will help you find that before you get it into your source control. Or how can you more easily manage your API keys using a key vault? Or, what are some newly reported vulnerabilities? We'll talk about them with each other to make sure that we can find them within a couple of days and fix those. We also have a security guild, and that's open to anybody who wants to become more of a subject matter expert in security. So you don't have to have any credentials to be part of the guild. If you want to come, we invite you to come. And this is a place where we bounce ideas off of each other. We drive implementation of initiatives. We're helping handhold teams through getting these tools into their pipelines. We make sure that the tech talks are happening on a regular basis. We invite outside speakers in, and so on. And of course, we have our documentation. So it's really important to clarify and document what are the best practices, what are the tips and tricks, and how to set up these tools. And I personally find that sample code and how-to step-by-step guides, like how to get this tool working in your pipeline, are the most powerful for getting tools rolled out across the organization. And of course, let's not forget about Slack channels. These are an excellent way to collaborate with each other. So we have, at a corporate level, we have channels for cybersecurity and a channel for each of our different application security tools. We have Devops channels, and we have channels for post-mortem best practices for our front-end developers. At the business unit level, we have channels about information security and data privacy, because that tends to be a little more specific to what we're doing. And then at the lower level, at the platform level, we have channels for our tech leads, our operations leads, per squad to talk to each other, right? And by the way, I should clarify, our developers are running their own stuff in production, but we also have a test and operations team, which is focused specifically on operations best practices. So they will not take over your operations for you, but they will teach you how to do your own operations. And of course, it's important to get outside of our own bubble, right? We don't want to just be an echo chamber. So we invite in external speakers. We encourage people to take external classes and get certifications. And certifications are great because those are portable, even if you go to another job later. Another thing we can do is learn from our tools. So these security tools, when they detect a problem, they put out a very detailed report usually. And if you just take the time to read the report, it will tell you, what does this vulnerability mean? What does it look like in your code? How do you fix it, right? How risky is it? And of course, we can go to conferences. And part of our culture is that if you go to a conference, when you come back, we expect you to run a tech talk and share with everybody else what you've learned. Another kind of cool thing we did was called the Toolbox at IBM and DevSecOps Summit. So we actually invited our tool vendors in to run a mini conference just for us. And we did this at multiple sites where we had maybe 1,500 developers. And they were happy to do that, because by coming in and giving their conference talks for us and having a booth and asking our questions, they were increasing the adoption of our tools, right? And making us more likely to keep buying their tools. And for IBM, it was great because we're getting more and more developers engaged with the security tools and adopting them. Now, when you're doing all these things, you're going to naturally have a more excited and engaged workforce, right? So they've seen the concrete threats. They know what to look for. They have the control to do something about it. They're not wasting a lot of time with paperwork. It's mostly shifted left into the very earliest parts of the development process, and they're sharing with each other. A few things that are coming up next for us that we're working on. One big project is to sunset old infrastructure. So the people who are still managing their own virtual machines, that don't have the infrastructure as code, that don't have the continuous delivery pipelines, are sort of stuck in a place where all they do anymore is put security patches on their systems, right? Nobody wants to be in that position, so we are actively working on moving as much as we can into the cloud, into the DevOps pipelines, and getting that automated. Another big project we're working on is more Kubernetes and Istio security automation. So Kubernetes is, our strategic platform for large-scale automation going forward in the IBM cloud. And so we're putting together a lot of playbooks that show how to automate not only a DevOps pipeline in general, but specifically security. So, how can you keep your images up to date with the latest patches? How do you use the ingress controllers and Istio to manage the traffic flow and tweak the configuration so only the traffic you expect is getting through to your applications? How do you make sure that only HTTPS is accepted and not HTTP? These are all things that we can automate and share with our customers and with each other. And another fun thing we're doing is security metrics and KPIs. So our test and operations team is putting together a DevOps dashboard that we started with a lot of operational metrics on there, like availability. We put a lot of development metrics in there, like what is your test coverage percentage. We're starting to pull in more business metrics, things like how is our platform performing in terms of sales. We're going to pull in things like happiness metrics. And then we are also putting security metrics in there. So security metrics might include things like, what is the amount of time from when a known vulnerability is reported to when it is deployed and fixed in production, right? So how long are those known vulnerabilities out in production before we've patched them? Or what percentage of your builds are failing due to a discovered security problem? So that one's actually a little bit tricky, because if the percentage is 0, it probably means you don't have any automation in your pipeline that's checking for security. But you don't want your builds to be constantly failing either. You want them to be fixed quickly. So we're getting those on the dashboard so that our squads can see what their own performance is in terms of security, identify the places where they're lagging, and decide what they're going to focus on next. So just in summary, I think we will always have the traditional IT security. We're going to need top-down mandates. We're always going to have security at the end. We're always going to have some rollouts that have to be manual, and our checklists and spreadsheets aren't going away. For one thing, the law requires that we have these things, right? And this is part of our education. This is how we teach people how to do security right. We're always going to need specialized experts, people who, for them, security is their life. And visibility and control at the corporate level is great, because sometimes you need to be able to have a holistic view of your system in order to really see what's happening. But DevSecOps is helping us engage more people in the security process. We're shifting left so that problems are being detected very early in the process. We're automating more, so we're spending less time on manual effort. Our developers and operations people are excited about security. They care about it. We're sharing our knowledge with each other, and we have much more control down at the low level. Thank you very much. If you'd like to reach out to me, I'm Duke Ammo on Twitter, and you can also find me on LinkedIn.